Hello and welcome to another video. Today I'm going to show you one of the applications I've recently created. That application will act as an RAG, that is Retrieval Augmented Generation. RAG is nothing but the AI answering through one of the documentation. It doesn't need to search everywhere or search web. It just needs to find the answers using one document which we upload, right? So before we start, I'll tell you what I'm going to use over here. So I have Ollama installed in my system, and I'll show you what all models I have. So these all models I have in my system. I'm going to use Qwen 3 embedding for the text embeddings, and I'm going to use Llama 3 for this purpose. Llama 3 is a general purpose AI model, so it will work best for us. So before we start, I'll tell you how I create the application. So I have a IntelliJ IDEA Ultimate, and yeah, so inside Ultimate I have an option to create a new Spring Boot application. If I go over here, I get the option of Spring Boot, but in free versions you may not have this option. There is an alternative to it. So if you go to Google, just search for Spring Initializer and open Spring Initializer, and the same window opens, which lets you add the dependencies and create the application, and you can just download it as a jar. I'll give you one sample. So this is the application I'm gonna use. I'm gonna use Spring Boot 4.1.0 and Java 25, and let's add the dependencies. So first I'll need is Ollama, that is an AI dependency, and then I use Lombok. I'll tell you where I use Lombok. So it basically removes the boilerplate code from your code, and create the clean pojos and create the clean classes. So I'll show you where I use it. And then I use MongoDB. So MongoDB I'm using just for the AI purposes, and I'm gonna store the vector embeddings of the documents we upload. That also I'll show you where I do it. So if you have these three, and I think there is one more I use, which is JPA. Okay, sorry, JPA we don't need because it's not a Spring application. I think MongoDB will give you Mongo repository. We'll see. We can always add more dependencies, and once you have everything, you generate, and the system gives you the demo application, which looks like this, and this is how it looks like in our system also. The basic structure of the application, wherein you have the source and you have the POM. If you have used Gradle, then you will have build.gradle file and so on and so forth. But yeah, the basic structure is created, and it's given to you, and after that you can write your code. The basic structure has one of the Java class, which is demo.application, and it's similar to any Spring Boot application class. It has the annotation Spring Boot application and the basic code of any Spring Boot application. And if I show you it in my project, for my own specific project, local search application, it's same, right? So we don't need to worry about this. We don't need to change this. We don't have any arguments also, so we don't need to worry about this particular code. But yeah, this is the starting point of the application. Once we run this application, then everything gets started, right? So this is what I wanted to show you. And one more thing, we can always change the port and other details, but by default it runs on 8080, and Spring Boot already has the Tomcat plugged in, so it runs on Tomcat. But any reactive application, we can change the server to any other server, and for reactive application, it specifically has netty server, so we can always change the server by excluding it from the Spring Boot application and add a new server dependency. But yeah, this is what we get by default, and this comes handy for everything, because the basic application also works quite smooth. So this is it. Well, once you open the application and once you see the application, there is I forgot to change it to Maven, and I added the Gradle. But yeah, the project I created, it's in Maven. Currently this file is in Gradle, and if I open it, yeah, so if I open it, there are some basic dependencies I did over here, and we are setting the properties over here, which is the versions, and yeah, other dependencies over here. So a very basic structure for a Gradle file. Maven looks the same, and this is what my Maven pom.xml looks like. So it has the basic application, which is the parent application, which is a Spring Boot, and this is my application's version and the other details. And then we have the Java version and the Spring AI version similar to that. I have the Netty over here. I don't know. I think I've selected it while creating it, but currently I'm using Tomcat, and other dependencies I've added for vector generation and vector embeddings and so on and so forth. Dev tools and Lombok were selected for dev tools, and yeah, other plugin details. Just the basic Maven generated code. So I'll tell you now how I started. I have the basic configuration, which is the chat configuration. Chat client is the primary bean which lets you utilize AI features in Spring application and any Spring Boot application with any model. So you just set your model details inside this resource file, which is application YAML. You may see it as application properties also. The structure changes, but the basic details don't change, right? You in properties file, you have this dot this equal to this. Here we just have a colon and indentation kind of a structure, but it's the same, right? Now for chat, I've used this model as Llama 3 latest, and it's at this path spring.ai.ollama.chat and dot model, which sets the model over here, and whatever model I'll set over here, that gets returned as a chat model. Now chat client is the file or the class we are going to use to chat with the model directly, and default system is the basic prompt wherein you tell your model how to return anything or how to reply anything, right? I've just given a dummy prompt over here, that be concise and answer to the point. But yeah, we are going to see it forward, that I'll give some specific commands also. For example, this you are an expert helper, use the context from the document. This is for the vector chat client, and I don't use it specifically. I generally use it, and I'm currently using it. But yeah, just to give an example that okay, this has an advisor, this has a vector store also. So we are providing the document, and using this vector store, it uses the document and it uses the vector embeddings inside the chat. But yeah, don't worry about it. We are going to see it further. Vector store I have not used over here because currently I'm handling it from the YAML file itself, wherein I have this spring.ai.vector store, and I'm providing the details as Cassandra store and Cassandra index. I don't know why I named it Cassandra, just the name popped up in my mind, so I did it. And initialize a schema actually initializes the index inside the Mongo. Otherwise, by default, you'll need to manually create it. I'll show you how to create it, and then you can relate this particular piece over here. Other than that, just the application loggings. I told you I needed the loggings from Mongo, right? This is what I have set, and that's why I enabled the auditing in Mongo. So yeah, this is the basic part. Now I'll show you after the configuration how we can run the application. So I have this Ollama chat controller, and this is the this is the very first API endpoint, which is API v1 Ollama. That's a get mapping, and that's a get API endpoint. So if I have an input, if user provides an input, the model will give you an output. So the chat client, we are using it directly, and if you see this required args constructor, and I have not used any auto wired over here, right? Why I have not used auto wired is because I'm using the constructor injection. That's why I have this private field over here, a private final field, and manually if we create if we generate the controller, we generate it like this. So generate the constructor, and yeah, this is how it looks like. And if I generate it manually, you see it becomes a red mark because now we already have a defined constructor, right? But we don't need to write it like this, we can just utilize one annotation, and the annotation takes care of all these things. And this will also avoid any of the issues. Let's suppose I need to remove this. Now I need to remove it from the constructor also. We don't need to worry about it. Lombok handles it for us. That's why I use Lombok every now and then for every pojos also. One more place I'll show you I've used is so this is a record. I may have used one class over here, and yeah, if you see getters and setters, then I have this Mongo class field, right? And I have not used any setters or getters. I have not created any setters or getters manually, and just these annotations will help us. There are multiple annotations that Lombok provides. You can any day go through Lombok's documentation and read through it, how many annotations are present in Lombok, and it will give you the gist. But yeah, this is how we work with Lombok. So I'll go to the controller again. This is the default controller, and I've used the chat client directly. Dot prompt dot user, and the input is whatever the user provides. It has one default value. It is not required, but yeah, it has a default value. Suppose user doesn't provide anything, then this particular text will go to the AI model as a prompt, and then I'll say call dot content, and once the call gets triggered, the model replies to this particular API, and yeah, then I have the content of it. So this is the return type. Whatever string I'll need from the AI model, this thing will get everything to us. And one more thing, yeah, so Ollama I'm using like this. So I'm using a base URL which is my local URL, right? It has localhost. So since everything is there in my system, and I'll be running the API. So the API call is made to my local Ollama model, and then the solution gets returned, or the response or answer gets returned to my application. So this is how I directly connect to an Ollama model, and this is what Spring AI looks like on a very simple level, right? But yeah, we can have some more detailed prompts. So suppose for example, I have given this as a system prompt, that my AI knows that okay, the user is not asking it, but as a developer you can ask your AI model to act as something, or just give your AI model as the default prompt. So this is how we give the default prompt, and then there's similar thing, user input, and then instead of call here I have used stream. So stream actually returns the stream of string instead of direct string. So if we call this, you get the response directly, but if we call this slash stream, then you get the stream response, just like we get in ChatGPT. It types, you get the feeling of Chat API typing it on your screen. I forgot one more thing. This is the value, and then it provides produces event stream. So yeah, this is how it produces the stream. And if we go to the document now, this is where the magic happens for us. One second. No, then this is not the correct API. Yeah, so this is where the magic happens. So I have this document initializer, and I have added a manual document over here, but you can always provide the document in the API as a file. But I wanted to simplify things, so I have hard coded it in the resources, and I am reading it from the resources directly. So if I hit this document.init, my local system will initialize the document, and it will save the vectors vector embeddings to my vector DB. So if I open my Mongo and show you Mongo Cloud, and by the way, I'm using a free Mongo M0 cluster. So it's free for me, it's free for everybody. And I have this data explorer. I'll show you MongoDB, right? So MongoDB has this Cassandra store, right? Which is what I've already shown you. So as soon as I hit this init, this Cassandra store gets created, and then the vector embeddings gets created. You see there are embeddings, right? Which are generated for this particular text, and this is the content I have for which the embeddings are generated. So the whole document gets loaded and gets divided into chunks, and those chunks get stored over here, and then the embeddings gets created so that our search becomes faster. And I showed you one field, right? Initialize schema. So if I set it to true, you will by default get this index created for you. So if you see, one second. Why is it slow? Yeah, if you see this Cassandra index, the index is by default created for you. The dimensions and the similarity method, everything is answered in one of my blogs. So if you go to nemo.medium.com, and easiest way to understand the vectors. So I've already written the blog to show what are the dimensions, I mean how many dimensions are there, how to understand the dimensions. Everything is there in my blog, so you can always read the blog. But yeah, so number of dimensions actually helps the AI model to kind of find the similarity between two objects. If you upload one text or ask one text or ask one question, it can easily answer which section we are talking about specifically, right? So if I go to the application again, yeah, so this load resource will load the resource from a path, and if you see, I have this class path, right? Rag resource name. So resource name is this currently, which is there in my application. If you see this class path Java not this one, I have changed it. So yeah, this Java performance resource, it's actually a book, and it's a big book, so it was taking hours to load. For simplicity, I've changed it to this document. It's a 4650 page document, and that's how the embeddings were generated very fast. I mean, it took minutes instead of hours. Yeah, so the load resource will load the document inside the context, and then and this Apache Tika will split the document inside chunks, and those chunks gets added to the Mongo store. Now this vector store we are directly using, right? So vector store we have initialized over here inside YAML, which is over here. So we have already given the details, and the MongoDB details are over here. I have the password and I have the URL, DB URL. This is the username. So once these details are there, it will directly store create this collection and create the index for you once you load the document itself. So the document initializer just does that. It splits the document inside the chunks, into the chunks, and then we have this vector store that saves those chunks, and yeah, then we are good to go, right? I have added this event listener just to load the document at the application initialization or application run, but I wanted to segregate it. If I give the biggest document, then my application was never running, so that's why I moved it to an API, right? And once everything runs, then I have this acknowledgement sent to the request, to the API request, right? And after that, I can just utilize this vector store to answer my queries, and I have this stream over here. The same thing, I have not added producers over here, so it directly returns the string. But yeah, you get the gist. The system prompt, and then the advisors. There are multiple advisors present for any vector store. They asks for a vector store, and you just need to provide it. But you already have the bean created by Spring API. Spring AI. So you are good to go. So I have this question answer advisor, and I'm providing this vector store so that my vector store is utilized to answer this user queries. And then I have added the query. It's same as input. I'm just renamed the variable as query, and then I'm returning the stream. And yeah, this is what an RAG looks like, wherein I have the document loaded in the system, and the vector embeddings are created, and once you ask the question from the document, it uses the document's vectors and answers your queries and answers everything. So this is there. But if you want to manually create the index, you can always create the indexes over here. But yeah, just you need to make sure that whatever index you are creating, I'll use this. Yeah, whatever index you are creating, just make sure the same embedding models is used, because the dimensions are different, dimension values are different. You don't know what dimensions are, the AI understands it. So if we create the manual index over here, and we are using one of the Mongo's embedding model, then we can't utilize the embedding model from our local. We need to manually set the Mongo's embedding model, which is Voyage model. Voyage provides you an API key, and you can utilize it to create the embeddings of your own. But yeah, over here I'm using this Qwen embedding model, so that's why I've created the index using my Spring Boot application only, so that there is no mismatch. And trust me, I found it the hard way, that it was creating a mess for me, right? So yeah, after we run this and we ask the question, 1 second. Yeah, so if I create a new request over here and I run my application, this is API v1 Ollama solution, and the parameter I have is query, and it's a requested param. So localhost colon 8080 slash this, I think I have doubled it, slash solutions, and I have the parameter which is query, and the query is how can I connect with cockroach DB. And if I send this request, I hope everything is correct. Yeah, if you see over here, it has created the vector embeddings for the query I have provided, and it is searching it in Cassandra store, right? So this is how your RAG search looks like, or you can say vector search looks like. And if we go inside this, based on the request to connect with CockroachDB, I understand you are looking for a way to interact with the database system. And the document I have created, the document embeddings I have created is the documentation of CockroachDB that is in comparison with Cassandra DB, and that's why I remember, that's why I named the index as Cassandra index, and the collection as Cassandra store. So it gives you the basic code and basic instruction of how do you connect, right? So yeah, this is how you create an RAG. Yeah, so if you have any questions regarding any code or any specific line, I try to answer everything in my blog. So this is my vector embeddings blog, and I have another blog that is this, how to create the application, Spring AI application using Ollama, and it's basically free for you because Mongo M0 cluster is free. We are utilizing it for free, and then your local systems, local models are utilizing your systems CPU and GPU, so you don't need to pay anything to any external partner or third party. It's almost free for you, and then you have the application that is running on your own system that is also free. So yeah, this is what everything looks like, and I tried to answer everything from what model to use, why we need to use anything, and how do I utilize it, how do I initialize it, so that you don't need to worry about getting stuck at a specific place. Everything is answered over here. So this is it. If you have any questions just let me know in the comments below, and good night, see you.